Well, I hope you're all well fed, well rested, because this is super exciting stuff. My name's Joe Chilcote. I work at Facebook with the client platform engineering team, along with a couple of the other characters in here. And I'm going to talk today about automating yourself out of a job with Chef, and how we use our internal Chef API model to distribute the workload out to our end users. There's a few reasons that we utilize this Chef API model. One is that it can kind of foster a feeling of ownership amongst users if they can take part in the configuration of their own machines. It encourages buy-in from our user base because most of them are developers. They're used to working with APIs, and this is us speaking their language in a way. And plus, we may not, as central IT, we may not know all of the appropriate settings or apps or configurations that they need to get their job done. And it may not even be up to us to decide. It might be security or legal or HR or the groups themselves that come up with these configurations. So what makes it easy to do in Chef is everything's in code, which makes it easy to review and audit. It makes it easy to share ideas. We can build templates and have some stock Chef cookbooks that users can use to generate ideas on some of the sort of things that they can add themselves. And because everything's in code review, or everything's in version control, it's all reviewable. And anything that anybody submits has to be reviewed by at least one other person. And if it's going to touch some area that is considered security or privacy conscious, then somebody from security or any other group can come to them and ask them to provide further context or justification for the changes that they're making. So all you have to do really is just write a bunch of Ruby, submit it, get your neighbor to review it and approve it for you, land it, and next thing you know, the entire company has a new message of the day, and their screen display color is inverted, which is easy to do, actually. But we'll get to that in a little bit. But first, I want to provide some context, and I kind of want to talk about a different subject first, which is cats. But I don't want to talk about these cats. I want to talk about these cats and how those cats became this cat. So the domestic cat still lived outdoors for thousands of years, and only became, the house cat only became a thing about, 70 years ago or so, when they invented things like kitty litter and spaying and neutering, which was humans' way of customizing the experience of being a cat, right? So using the model of inheritance and convergence, they made the life of a cat more compatible with the life of a human, which allowed us to invite them into our home, at which point they took over our lives and controlled the internet. But it's because humans converged the natural cat behavior with desired cat behavior that they were able to do this. So what does that mean for Macs? Well, in computer science, there's also the concepts of inheritance and convergence. And as Mac admins, we encounter this with our configuration tools. So you may want a configuration that applies to one machine applied to several machines. For instance, like in a lab environment or a small organization, you might want to just have one set of settings applied to everything. Or perhaps we want a baseline of configs, and then maybe a separate config for a small subsection of the computer base. Or perhaps you have different hardware classes, hardware types, that might require different types of settings. An example might be You have some Mac Pros that are doing builds. You may want to have different power settings available to those as opposed to your laptops. And finally, we want to be able to provide configuration settings on a per user basis too. So traditionally, that would mean the user could log into any machine and get settings that are specific for their user environment. And traditionally, for the longest time, in the Apple world, we used Apple's Managed Preferences, or MCX. And in conjunction with directory services to provide a lot of these settings down to the machines and to the users. And at a high level, the configurations were at a user group level, computer, and user. And it would work in that order, right? So you would have settings applied to the user group first via some directory service. And then it would go down to the computer group. So anything that applies to the computer group might override the settings that were there prior. And then you could get as granular as you want and go down to the singular computer level or all the way down to the user who's using the computer. Does anybody know what this is?
Golden triangle. Yellow triangle.
The golden triangle. Those of you who might be new to the platform, you may not remember this, but there was a time, and I'm glad you're all sitting down, and sir, I would sit down if I were you. There was a time when we used to bind Macs to a directory service. Isn't that crazy? And not just one directory service, but two. Because we were mad. And actually, as an aside, the same people who popularized the golden triangle are the ones who are now selling us Nomad. It's a long con. So the OS would converge settings from both Active Directory and Open Directory down to the client and provide those settings from both directory services. Now, it's a triangle, and there's only 2 points, right? And that's because there was actually 3 directory services, one running local on the machine. And some of the more clever admins out there figured out a way to slipstream settings onto the machine through local MCX, which allowed us to have configurations applied to the machines without using a directory service, basically, or an external directory service. Well, then Apple came along and gave us configuration profiles, and all is good, right? Everybody loves configuration profiles. It does everything you need. Well, while config profiles are pretty easy to deploy, either through MDM, through the MCX2 profiles tool that Tim Sutton made, or directly via the command, the profiles command, we do lose some of the control and flexibility that we had with MCX and directory services. So we don't have the notion of inheritance and convergence in this model. So what do you think would happen if you tried to apply a configuration in a preference in a configuration profile that manages a preference domain that also exists in another configuration profile? Anyone? I actually don't know. I assume your computer just blows up. I don't think anything good would happen. How would it know which one to apply, right? Or what if your MDM decides to add keys of its own to a configuration profile that you may not know about, and you're also trying to manage that preference domain in another configuration profile as well? Again, bad times. This would result in a collision of preferences, right? So the system may choose one, may choose the other, may not choose either, may try to use them both, who knows. And there's really no easy way in configuration profiles to have a set once option. It's more of an all or nothing situation, whereas with MCX, you could have a setting like a screensaver apply at login, and then they could go in and make that change in system preferences. So what if you tried adding user-level configuration profiles into this mix and had a mixture of managing preference domains amongst different profiles? Or if you were trying to manage different hardware types, one setting for one machine, one setting for another machine, trying to nest all of that into a config profile would become a nightmare. And I don't even want to think about what would happen if you tried to do that. So we use Chef for all of this. And we can take advantage of the inherent behavior of Chef by knowing how it compiles and runs our cookbooks. By knowing how it compiles and runs our cookbooks, we can take advantage of it to enact the changes that we want. And we can even kind of emulate the MCX model of a group of users, group of computers, a singular computer, or a singular user. So a Chef cookbook consists of some directories, and this is just a high level. I'm not really going to get into the nitty-gritty of Chef because it's not really relevant to the talk. But you can think of it as a series of directories, each of which contains a variety of files that do stuff, right? And we're really going to only worry about a couple of these for this talk. The attributes directory contains files that you can use to kind of initialize settings that you want to apply. This is where you would set maybe a baseline, like a URL equals apple.com or blank. The recipes would be where you could have a specific setting for a specific cookbook. So you could have that URL equal facebook.com or google.com based on what cookbook is running. And finally, the resources is where Chef finally converges all the settings and applies everything to disk. And the reason that we can take advantage of this is because we can deterministically make the config changes during the Chef run. We know the order in which it runs. So Chef does, at a high level, does 3 passes. I think it does actually like 5 or 7, but anything beyond 3 and I get super confused. And on the first pass, it goes through all of the cookbooks and it analyzes the attributes and collects all that data into a node object. So it just grabs every key and value it can find and creates an object out of that. And then Chef starts over, runs through all the cookbooks again, and processes all the recipes. And this is where the meat of the API stuff happens. We can change the default value of these attributes by adding new values in the recipes. And when it comes along, it'll just pick up that new value, overwrite the old value, and then that becomes the new default. This is where the inheritance part comes into play. And then finally, it goes through the entire list again and processes all the resources, at which point it's actually taking everything that it knows about your node object and doing with it what you want. So you could write to disk, you could create a configuration profile, you could alter other settings, you could run scripts. Really anything that you can run via Ruby, you can do in a resource, so you can shell out if you want to at that point. And because it had already gone through all the attributes and all the recipes, the last value wins, right? So in the attributes, you set the URL to nothing. A recipe comes along, sets it to apple.com. When it goes and converges, and writes to disk, it's apple.com. So that's all well and good, but what if you have two different recipes that are managing the same attribute, right? So you have one recipe that's changing it to apple.com, another one's changing it to facebook.com, another one's changing it to google.com. Well, because we know the order in which Chef processes cookbooks, we can be deterministic about what the value will be at the end. So this is a very simple run list that you could apply. And at the very top, you would have the base setting, which would apply to the entire fleet. And then as Chef runs all of the recipes and moves down that list, those attributes might be updated to what you want them to be. And we put the user and node customizations at the end because those are the most granular. So you would want anything that you put into your own user customization to overwrite that attribute on every Chef run. So again, Chef does three passes at least, three passes that we care about for this talk. The first pass, you want to initialize a setting. Usually you just make it nil or false or 0. And then when it comes back around, it may or may not find an updated value in the recipe that somebody has defined. In this case, you would set it to true. And then when Chef converges, it writes to disk and everybody's happy. So this should begin to make a little bit more sense as I go through some examples here. In this example, I'm going to make a change to the login window. Using the login window configuration profile. So on the first pass, we just throw every setting that we can think of in there and call it nil or 0 or false. In this case, we're just making them all nil. And we do this because if none of these values ever get updated in any recipe further along down the line, then when Chef comes time to converge and write to disk, it won't do anything because there's nothing to apply. So you won't end up with a configuration profile with 0 settings. And then when Chef comes back around and starts running and looking at all the recipes, in the base settings, we might have a couple of default settings to add in here. So we want to make it the show full name, which I think makes the username and password field hide 500 users. And the admin host info, I think, is the thing that makes you be able to click in the top and it shows you the IP or something. But this is the sort of setting that would apply to your entire fleet, right? Because it's in the base settings. It's the first cookbook that Chef is processing as it goes through the run list. And then here, I have a customization that I made for this talk. And I'm just adding login window text. So it's the text banner that would show up on the login window, right? And throwing in a custom line with the host name. So it's pulling the host name from what it knows from Chef and putting it into the login window banner. And because I'm not overwriting any of those other settings, they'll still apply. This just adds this to the array. And when it comes time to build the configuration profile, it'll use the settings from the base settings in the previous slide and everything in here. So it's really not important to know what this is doing, but this is just building the config profile. And at the bottom there, it's taking any of the keys and values that were defined in that attribute and through all the recipe runs and putting them into the profile. So the result is you end up with a configuration profile in the system and you have your text banner with the host name showing your host name at the bottom. Oh, also, I just wanted to point out that having done this, I can say I've now deployed Rush lyrics to like tens of thousands of Macs. So it's very exciting. So another quick example is the Spotlight exclusion list. We have an empty an empty initialization in our attributes file in the CPE Spotlight cookbook. It just makes an empty array there. But then a recipe can come along at a later time and add a folder or an item to the Spotlight exclusions. In this case, I'm just adding a folder called source in my home directory and slipping that into the CPE Spotlight array there. And again, I did this on purpose because it's really not important to know what this does, but this does stuff, and the result is you end up with a configuration profile that inserts all of those settings that were combined through the chef run. And you end up with a properly configured Spotlight exclusion list there. So this one's a little bit more complicated. We configure, or we install Monkey with Chef, and I think we also install Chef with Monkey. It's kind of a battle that goes on there. But we initialize the Monkey versions in the attributes file to be blank. Again, it's nil, which means when it comes time to converge and write to disk, it's not going to do anything because there's nothing to do. And then in the base settings, the only important parts here are the version. So we put the stable version in the base settings. So this applies to the entire fleet. They would all get version 3.11 installed. But then along comes a recipe in another cookbook. Say it's a testing group. It could be your own group. It could be just for your user. And this applies different values to all those same attributes. So as Chef comes through, it just overwrites those old values with these new values, and then it'll use this when it converges. So this is a great way to do kind of a testing rollout of a product. In this case, we're just pushing the newest version of Monkey to a small subgroup of our fleet to make sure that there aren't any issues before we begin to roll it out to the entire fleet. And again, when the resource comes along, it's just a Ruby block. The details are not really important, but what it's doing is it's grabbing the version that Chef knows about. And for the vast majority of the fleet, that would be 3.11. For the group that you defined to get the newest version, it would be 3.12 or 3.2. And then it installs the packages for you. And the last example that I want to talk about is our friend Nomad. We've been playing around with this lately. And the latest version of Nomad has an action submenu. So the idea is you're going to be able to include your own actions. And they could be anything from like running a script, opening a URL, sending a notification, or opening an app. Really anything that you could script, you could throw in here. And the idea here is that we would have some default actions that we would provide for our users as the central IT department. And then we open it up to them if anybody has any ideas to add any additional actions that for themselves or for their team or for their department. They can do that via the Chef API. So again, we initialize everything as nil because we don't want anything to happen if the settings have no value. And then in the base settings, this is where we supply the actions that we want to manage and we want to be on all machines. In this case, it's just a script that runs Chef at this point. And we add a separator there as the second element in this array. And that way when somebody creates a new action, it'll be kind of nicely sorted in the submenu underneath a separator line. So here's an example of something that they could add. I just made this notification action to be, and this will be added to that hash of actions. So when Chef runs, it'll create the configuration profile, set it, and when you load Nomad, you'll get your own action as well as the centrally managed one. And then once again, the resource comes along and builds the configuration profile. And the details aren't really important here, but again, it's just shoving all of the information it knows about this setting into the config profile locally for you. And so this means that you're not installing one config profile everywhere. The people who get the extra Nomad action menu item would effectively get a different config profile applied to their own machine. And you end up with something like this, which when you click notification, you get Carrie the Caribou telling you something. So again, it's a 3-pass run that Chef does. First, it just grabs all the initialized values that are provided. Then it goes and looks for any updated values. And because we know the order in which Chef runs, we can determine the values that would apply to specific machines or group of machines or users. And then when Chef converges, it just takes all those values, shoves them into whatever it is you're trying to do, whether it's a config profile or installing an app, or dropping a file, anything that you're using your config management for. And that is how we use the Chef API to apply configurations to our machines. And that's it. Any questions?
Anyone?
Okay, that sounds great. You're creating a profile on the fly at the end of the run, and you're installing it locally. And I'm guessing people can just take it off if they wanted to?
Sure.
But it will just come back in half an hour or something?
Yeah.
Right?
Yeah, and that happens. I do that sometimes with, if I'm remoting into one of the imaging servers or something, and we have the screensaver pop up like every minute or something.
Mm-hmm.
Sometimes I'll just delete that profile so that I can do some work, and then when Chef runs again in 30 minutes, it'll reset that config profile.
Okay. And what does the infrastructure, I'm sorry, this is just around the whole Chef thing, we're kind of new to it. What does the infrastructure for Chef looks like? What do you need to have to be able to just, deploy these kinds of recipes, cookbooks?
Well, you can use a Chef server with it, and then the clients would check into the server to get the cookbooks. If you wanted to, you probably could utilize Chef Solo and just copy down the cookbooks via Monkey or something, mm-hmm. And then essentially the Mac would just use itself as its own Chef server. Cool. I've never tried doing that. I think Mike was playing around with that recently.
So you're coming from a Puppet infrastructure, and so we're comparing everything to what we
have. It's similar to masterless Puppet. I think it's called
exactly.
Chef Solo. Yeah.
Cool. Awesome. Yeah. Thank you. Mm-hmm.
There's one in the back. Almost got away. I like this whole barrier thing. I feel like I'm on trial.
Thank you very much for your talk. One question: how do you handle profiles that are installed by the user and that might manage the similar preference domain to what you want to do? Are you just completely deleting them, or is there another way to handle that?
If they install their own configuration profiles on their own, and those might conflict with something that we're...
Yes.
I probably would just let their machine blow up and they can go talk to the help desk. Give the frog a mic.
I work with Joe. The other thing too, as an alternative to letting the machine blow up.
But we're only accepting questions right now.
It says Q and answers.
Okay, fair enough.
Is that because we do work in an environment of engineers, we also, you may have noticed it in one of his slides, there's user customizations and node customizations. We do allow for them to submit a diff that for their machine or for their account seen on their own machine, Chef could do something a little differently for them. As he was talking about, different machines can run a different config. So if the user, for some reason, needs a profile that manages that specific domain and they understand that it collides with something that we would by default provide, they would actually be able to submit a customization for their own machine that would opt them out of the management for that particular setting. And that would also allow us to have on record for an auditor or whatever that, the reason that this person chose not to do this particular managed setting is because it breaks X, and they were already managing that particular setting in a slightly different fashion for whatever their reason is or something like that.
Yeah, that's
So-
a good point. Something I didn't mention is the difference between the user customization and a node customization. Since we base everything off of Active Directory usernames, the user customization is just their Active Directory username.rb. And so when Chef runs, it looks for that because it knows who is running it, right? And similarly, it looks for the serial number. So if you make a node customization with your serial number, that customization will apply just to your machine, not necessarily to the user that's logged into it, which is helpful for virtual machine testing too, because we can have a VM with a known serial number. Like I have a VM that's just called VM Chilcote, and I have a node customization just for that VM. So whenever I spin that up to do some testing, Chef applies certain things to the VM, like installing VMware tools, for instance.
So I had a question. Is Chef just for managing configuration profiles?
No. It's a general purpose config management, so you can manage files, directories, packages, anything really, anything anything Ruby can do, Chef can manage. Yeah.
Thank you.
Sorry, just wondering, do you use this for managing computers outside your own network?
Users do leave the network and are managed, yes.
With the Chef?
Yeah.
Yep.
Can I just follow it up on the approval of node and user overrides? Essentially, I'm probably using the wrong terminology. I apologize. Is that a system that you guys wrote, and is it an automated system for the approval? How does that work? Because the only thing I can think of right now in my head, I'm seeing this nightmare of everybody asks for an exception. How do you publicize it? How do you manage that? How does that work?
I've made that joke that we're putting ourselves in danger of having 100,000 reviews to review in the next week if everybody puts in a bunch of customizations for all their machines. But yeah, it is the Chef API model, as we call it, is an internally created thing. It's not. I don't think it's something that Chef officially talks about, or we're taking advantage of the fact that Chef has a deterministic runtime.
No, I get that. But
so it's something that was developed internally on the prod team. And that's something that we've taken advantage of on the client side as well.
I guess my question is a little bit more about how, if I'm a developer, say, at Facebook, and I'm, how do I find out about the fact that you can do this? Is it word of mouth? Do you actually publish it somewhere?
It's word of mouth. I think during
yeah, exactly.
During new hire orientation now, they have them go through an exercise of creating a customization as well. But yeah, I think generally it's word of mouth. And usually people are using it for things like, I don't want this Chrome extension, or please stop installing Firefox on my machine. Or, I don't know, what's a good example? I mean, I know what I use it for.
Instant lock on screensaver, 60 seconds or whatever.
Yeah, and it can be used
Great.
for, so we do things internally for our own use, like auto package machines or auto package configurations. So there's an internal auto package cookbook that you can use, and if you use that as a cookbook API, you can add all the auto package tools to your own machine, and it'll include all the recipes that we care about. So you don't have to worry about going out and looking for all that stuff.
So essentially, you also use it as a choice for users as opposed to an exception necessarily? It's
Yeah,
just a
because we don't want to
choice?
install everything everywhere.
Sure,
Yeah.
gotcha. Thank you, thank you very much.
These are good questions. Anything else? All right, let's call it good. Thank you.